Okay, so for this warm-up, all you need to do is work out which quadrant your angle lies in. Remember that all trig functions are positive in 2 quadrants and negative in 2 quadrants. If you want, you can use this. Angry sounds traumatizes children, or students take calculus, or you can just do it by considering where x's and y's are positive and negative. So this piece of information here tells us 2 quadrants. It tells us our angle is somewhere between here's 0, here's pi, here's 2 pi. Our angle is somewhere between there and there. So it's either in quadrant 3 or it's in quadrant 4. And the cotangent is positive. Equals a positive number, that's not negative. And a cotangent is an x divided by a y. So to get something positive, I can either have a positive x divided by a positive y, or I could have a negative x divided by a negative y. So if I had a positive x divided by a positive y, I must be in quadrant 1. If I have a negative x and a negative y, I must be in quadrant 3. Where do those 2 pieces of information overlap? In quadrant 3. Okay, now that's just the very first step of a couple of different questions we're going to do. We're on unit 5.5, day 2, and we're going to have a look at these questions here now. We're going to find the sine of the double angle, sine of 2 theta, and we're going to find the tangent of 2 theta, but we don't know what theta is. All we know is from this information here and here, we know it lies in quadrant 3, and we know the cotangent of the angle, but we don't know theta itself. Let's get on with this then. So first of all, let's look at our questions. We're going to have to find the sine of a double angle, sine of 2 theta, and the tangent of 2 theta. So we're going to use for this the identity, and these will be given to you on a test. And the tangent, it is 2 times the tangent of theta over 1 minus the tangent squared of theta. So in order to be able to use these, I need to know the sine, the cosine, and the tangent of theta. So what we can do from the information we were given is we don't know what theta is, but we do know it lies in quadrant 3. So if we just graph an angle in quadrant 3, and say that is the single angle, just 1 times theta. We're going to be finding 2 times theta. But it's going to give me this information. That's 1 times theta and 1 times theta. So if I want to know the sine of theta, I need to know y divided by an r. If I want to know the cosine of theta, I need an x divided by an r. And if I want the tangent of theta, I need the y divided by the x. So I have to label up all the sides on that triangle. We were given the cotangent, and the cotangent is an x divided by a y. So I know my x is 5 and my y is 2. But remember, this could have come from, these must be negative. They're both negative, which does give me a positive cotangent, because you're dividing a negative by a negative. But if you label those as positive 5 and positive 2, everything you do will be wrong. So be aware of the fact if you're in quadrant 3, your x is negative and your y is negative as well. Now we also need to know the r. Now this is not a triangle, we know, so we're actually going to have to work out r. We're going to work out r using the Pythagorean theorem. R squared equals x squared plus y squared. So it's going to be x squared, which is negative 5 squared is 25, plus y squared negative 2 squared is 4. So r squared is 29. So r is going to be the square root of 29. So when I want to know the sine of theta, I can replace that with the y divided by the r. Negative divided by positive, it's going to be negative 2 divided by the square root of 29. Now, often in math, if we've been asked to evaluate the sign of that angle, we wouldn't want you leaving the answer like that. We'd want you to rationalize the denominator. But that's not going to be our final answer. So we're going to have to, when we look at the math we want to do, we're going to decide, do I prefer this form or do I prefer that form? Doesn't matter which form we use there, they're both equal, but one of them might make our lives easier. When I want to do the cosine of theta, that's your x divided by your r, so it's going to be negative 5 over the square root of 29. So that would rationalize to be negative 5 root 29 over 29. And when I want the tangent, well, it's just the reciprocal of the cotangent. It's going to be 2 over 5. Flip the tangent upside down, or just do your y divided by your x. Okay, so let's have a look at this sine one then. This is the first real question we're being asked about that information. To find the sine of the double angle 2 theta, we don't know anything about it. Okay? All we know is it's bigger than theta, it's twice the size of theta. But we have this identity, so we can say it's going to be 2 times the sine of theta multiplied by the cosine of theta. So I'm going to go and look at these. Now, which of these am I going to use? Would it be better to use this one for the sine and this one for the cosine? Or would it be better to use this one, the sine, and this one for the cosine? Look at the math we're going to have to do. We're going to have to multiply them together. I would much rather multiply these two together than these two. So I'm actually going to use the form of negative 2 over root 29 for the sine and negative 5 over root 29 for the cosine. So those go in here. The sine is negative 2 over the square root of 29, and the cosine, this part here, can be replaced with negative 5 over the square root of 29. So I'm multiplying fractions here. That 2 at the front, that multiplies just the numerators. Think of that as the fraction 2 over 1. So I multiply across all the numerators, and bear in mind I've got a negative times a negative times a positive. Overall, it's going to give me a positive answer. And I've got 2 times 2 is 4, times 5 is 20. And in the denominator, I've got 1 times the square root of 29 times the square root of 29. That's the square root of 29 squared, which is 29. Okay, so I don't really need to write that plus in front. Okay, so that was the sine of the double angle. Now, sines and cosines are much easier than tangents, just because of the nature of the math you have to do when you're working it out. So I'm going to make you do the tangent now. Let's give you 2 minutes and see how you do on working out that tangent. Off you go, guys. So with this, we're going to have a fraction, and in the numerator we've got 2 times the tangent, which is 2 over 5, and then we've got 1 minus the tangent squared. I'm just going to square that straight off. 2 over 5 squared is 4 over 25. So let's clean this up. In the numerator, that should be written as a fraction. So we've got multiply across the tops, 4 over 5. And in the denominator, I'm going to rewrite this 1 as I want them over a common denominator. So I want something with 25 on the bottom. So now I've got 25 25ths minus 4 25ths, which gives me 21 25ths. Now you can keep change flip. So you keep the numerator, and instead of dividing, you multiply by the reciprocal of the denominator, which means flip the denominator. And now you can simplify. You've got factors everywhere. 5 is a factor of 25, it leaves 5 behind. So now multiply across the top. 4 times 5 is 20. Multiply across the bottom, that leaves behind a 1. 1 times 21 is 21. If you went wrong somewhere, I hope you can find where you went wrong. There is a different way of actually sorting it out from there. You could have multiplied the top and the bottom both by 25 over 25. That would kind of get you there. But I actually think this keep changing flip technique's easier. Okay, so let's move on. So what we've done so far, there's 3 types of questions. This was an evaluate question. Well, we're just given an expression, and we actually have to find the value of it. So we've ended up with a number. A number is a value, yeah? That's the answer when you've been asked to evaluate. You come up with a number that you could graph on the number line. The other types of, we also have to look at solving and simplifying. So let's look at simplifying next. So one of these, we actually, when we simplify it, we end up with an angle we know, and one of our special angles, so we'll actually be able to evaluate it without using a calculator. So when you're given, like this is supposed to be question 1, and the one's not shown at the beginning. Can you see, compare it to your double angle identities? Can you see it looks really similar to part of one of these identities? It looks really similar to this. And if we had, if this said 2 times the sine of 15 degrees times the cosine of 15 degrees, if that's what it had said, we would have this side, which is equal to, so can be replaced by this side. We'd have the single angle side, and we could replace it with the double angle side, yeah? All of this together, you don't break that up into pieces. The whole thing gets replaced with just this, because it's equal. The problem is, though, we didn't just have 2 times the sine of 15 cosine of 15, we had 100 times it. So this was just a multiplication problem, 100 times the sine of 15 times the cosine of 15. We can factor that 100 into 50 multiplied by 2. So there's my 100, there's my 100. Now can you see what we've got there is we've got 50 multiplied by this. And that stuff in green is this, and I can replace it with this. So what I've got is I've got 50 times the green stuff, and the green stuff can be written as the sine of the doubled angle. Well, my single angle is 15, my x is 15, so when I double it, I have 30. And I want the sine of 30. Oops, that doesn't say sine of 30, that says sine 30. Okay, so we've got 50 times the sine of 30 as it simplifies to that. Now you can only stop there if we were simplifying, but look at that one. 30 degrees is one of our special angles, and we should know the sine of 30 degrees. So this one we can go on to evaluate. It's going to be 50 multiplied by something. What is the sine of 30 degrees? Draw it. 30 degrees is there. 30, 60, 90 triangle. That's 30 degrees. That side's 1. That's the long leg. That's the 2. So the sine is the y divided by the r. It's 1/2. So this actually evaluates to 50 times 1/2, which is 25. Okay, so that was this first one here. The second problem on this page, I think, is the hardest. Looks really quite simple, but it's kind of the most confusing. You can see we've got a sine times a cosine. Now, the only one of these identities that has just a sine times a cosine is this double angle identity. But this double angle identity doesn't just have 1 times the sine of 40 degrees cosine of 40 degrees. It's got 2 multiplied by it. In our question, we've just got 1 multiplied by the sine of 40 cos of 40, and we want this to look like 2 times the sine of 40 cos of 40. But what I write on this line has to equal what's on the line above. How can I make a 1 have a 2 times there? If I rewrite that 1 as 2 divided by 2. So what I'm going to do is I'm going to divide that by 2. Now I've got 1 times the sine of 40 times the cosine of 40, but the 1 is written as 2 divided by 2. So I've got, again, what I've got in the numerator there, this stuff here is literally this, where my x is 40 degrees. That can be replaced with the sine of the double angle. So the numerator in this fraction can be replaced with the sine of the double angle. Well, if 40 is the single angle, the single x, the double angle will be 80 degrees. But don't forget this divide by 2. So that's a perfectly good answer. Another way to write that answer would be sine of 80 degrees. Dividing by 2 is the same as multiplying by the reciprocal, multiplying by half. Now this one, we cannot evaluate because it's not an angle we know. We're just stuck with simplifying it. Let's think that's our answer. The other answer would be good as well. And then this third one, when you look at it, you can clearly see that's a tangent. We're doing something here with tangent. So look at this double angle identity for tangent. And think, oh, that doesn't say 42 here, it just says 2. How can I make what I've been given have this as part of it? I want this in my work, because when I see this in my work, I can replace it with this. But we didn't have 2 at the front there. We had 42. So what I'm doing here is I've got 21 times 2. That's the same as if I put a parentheses there. That's like multiplying by the fraction 21 over 1 times the blue stuff. So that gives me 21 times the blue stuff. And I said when I'm given this, that blue stuff up here, this blue stuff up here is exactly this. And where I see an x, I've got a 25 degrees. So my single angle is 25 degrees. And I can replace all of this, it's equal to, so it can come off. And in its place goes this, the tangent of the double angle. If my single angle was 25 degrees, my double angle is 50 degrees. Okay, so that was some examples of simplifying. So you've got this, your homework worksheet. You've got lots of these sorts of simplifying questions, and you've got a couple of equations to solve. Now, on your homework, you've got these questions, 20, 21, and 22. 21, try it without looking at yesterday's work. But if you get stuck on 21, go and look at what we did yesterday, and you'll notice this really is just almost exactly like a question we did yesterday. So I'm going to do question 22 with you now. I'm going to talk you through how to do it. And then for your homework, you're only really going to have question 20 to do. And you're going to have an exit ticket that's one of these sort of ones. And it's just going to be a classwork grade, and a lot of the points come from effort. So don't be worried about it. I want you to do the exit ticket to the best of your ability. Let's have a look at 22 now, though. So when we look at this equation, I hope you realize the first thing you notice when you're looking at that is that the angles are different. You see this squared, it's quadratic, but a bigger problem than it being quadratic is the fact that the angles are different. You can't have cosines of one angle combined with, trig functions of a different angle. It makes it very difficult to solve if you have that. So the first thing we want to do is to rewrite this equation so that
all of the functions in it are using the same angle. So we're going to replace cosine of 2x using one of the double angle identities. And for cosine, we've got three choices. Sorry, that's not on my pointer. Let's get this into my pointer. Oh, come on, machine. So we've got three choices with a cosine. One of these choices is going to make the work so much easier than the others. Try and picture what this equation would look like if you took out the cos 2x and you put in one of these in instead.
So we're going to get cos 2x and we're going to substitute in its place one of these three. This one will work incredibly well. This one will make your life very difficult. And this one, it would work, but it's a bit more work. It's going to really make your life easy. Can you picture why? If you can't, let's just write it out. So where there's cos 2x, I'm going to write cos squared x minus sine squared x. Then I've got the rest of the equation. I'm solving for 0 is less than or equal to x is less than 2 pi. I'm trying to find the angles that make this equation be true. So when you're solving, you have to write out the entire equation every time. You can't solve if you haven't got an equal sign and stuck on both sides of equals. Otherwise, you're not going to be able to solve anything. Now, can you see why using this top identity here was fantastic? Now you've got cos squared x, you're subtracting and adding the same thing. That's a zero pair, they cancel. If you put in here 2 cos squared x minus 1 plus sine squared x, you could get the, oh no, that would be horrible. That would be so much work, it would be almost impossible to do. You'd have a horrible time there. You'd get there, but it'd be a lot more lines of work. And the same if you'd used the third choice. You'd get there, but it's just a lot more work. This has made this pop out really nicely. All we're left with now is cosine squared x equals 1/4. Now remember, we're solving. We're trying to solve till we've just got x on this side, so we have to get rid of squaring and rid of the word cosine. So the first thing I'm going to do is get rid of the squaring by taking the square root of both sides. And remember, when you take the square root, you always have to consider both the positive and the negative root. So that would leave me with taking the square root of squared, leaves me just with this stuff underneath. Cos x equals plus or minus. When you're taking the square root of a fraction, you can just do the square root of the numerator divided by the square root of the denominator. So now all I have to do is find the angle x. So we know that the cosine of the angle is plus or minus 1/2, and we know a cosine is an x length in a triangle divided by an r length in a triangle. So I want to draw the triangles, and I've got to draw them in the right quadrant. Well, if the cosine was positive, we could have a triangle in quadrant 1 or quadrant 4, because the x's would have to be positive. If it was negative, we'd have a triangle in quadrant 2 or quadrant 3. Okay? This would be with the x being positive 1 for those two, and the x being negative 1 for those two. And we know that the r is 2, so that side is 2, that side is 2, that side is 2, that side is 2. So now recognize those triangles. It must be one of our special angles, otherwise we couldn't be asking for it without a calculator. So what triangle have I drawn there? Is it a 30, 60, 90 or a 45, 45, 90? I hope you're not thinking it's a 45, 45, 90, because if it's 45, 45, 90, the sides go 1, 1, square root of 2. They don't go 1, 1, 2. That wouldn't be a triangle, that would be a straight line. Okay? So it's not a 45, 45, 90. It's a 30, 60, 90 triangle. And think about the length of that third side. That must be the square root of 3. So this angle in standard position is opposite that long leg So we're looking at the 60-degree angle. So in quadrant 1, we want our answers in radians. It would have said at the top that we were solving here. That's telling you it's got to be in radians, not degrees. So I can't write that answer as 60 degrees. That angle there is pi by 3. In quadrant 2, that would be 2 pi by 3. In quadrant 3, remember you get, it's a bit bigger than a whole pi, so you add 1 to the denominator. And in quadrant 4, to reach this terminal ray here, that angle there, denominator is 3, quadrant 4, double that, get 6, take 1 off. So this problem has got 4 answers. Oops, I should have probably written x equals. Right, so that was solving a